Very good. That was short and sweet. Welcome, everyone. Thank you for attending this webinar. Subject today was presented as selecting a dosing pump. A dosing pump by itself is not much use to anybody. You really need to put it into a system. So the aim of this presentation is to give you some thoughts, some examples of what you're looking for when trying to create a dosing system. And at the end, there's a few dosing applications to give you some idea of market and where this stuff can be used. I hope you can all hear me well. If you do have questions, I don't mind answering them online. My key typing speed is somewhat of a snail, so we might be here for a while afterwards if we're going to answer them all that way. But anyway, we'll push on. Okay, so selecting a dosing system and dosing applications. So generally, yeah, customers are often a funny bunch. Sound is cut out for me. Can anybody else hear me? Hopefully somebody can let me know.
I've got the sound okay, Peter. Anyone else, if you can't hear, please let us know in the chat box. I know, okay. Rory, would you like to, oh, hang on, he can't hear me. Keep going, Peter, sorry.
Okay, I will continue on, and hopefully others can come back in again. Okay, so yeah, customers sometimes they want something, but they don't know what they want. They have an idea, but no idea how to implement it. And then I expect you to know the answers because you sell the equipment. So you need to find out what they're looking for. And often they'll come to you with questions like, I want to disinfect the water to my chook sheds. I need a pump to fertilize my irrigating system. AgTech Boffin says I need to drop the pH from my blueberries. Can you give me a dosing system? Where do you start? Where do you try? From a Grundfos perspective, dosing pumps come in many variants, different shapes and forms. There are different types. Digital pumps, where you get a display that shows you what's going on. Mechanical pumps, where you only have the mechanical stroke adjustment. Hydraulic pumps for high performance, long life, etc. Different control methods. Electronic control, where everything is controlled internally. Manual control, where you adjust the stroke length or movement of the diaphragm. Frequency control, where you have a VSD and change the motor speed to change the output of the pump. Of course, there are a couple of different power requirements, single phase, three phase AC power. We need to know what's available there. And we're not dealing with water, we're dealing with chemicals. Some chemicals are very aggressive. They can attack metals or plastics. So we have a range of head materials, valve balls, seals, etc., to make sure that the pump is compatible with what's being used. Head materials in PVDF, PVC, polypropylene, stainless steel, Biton, EPDM, Teflon, ceramic and glass, all different head material combinations that can be used for various types of chemicals. And then we have connections, different sizes, shapes and forms, DN8, DN20, DN32, different sizes of connections, different connection types, unions, flange or hose barb. Grundfos make over 100,000 dosing pump models. Take all those different combinations and sizes into account. So where do you start? You need to ask the customer some questions. What volume pump is needed? You know, is it a new or replacement pump inquiry? As if it's a replacement pump, what size is the existing pump? It gives you a guide to what you're looking for. And is that existing pump large enough, or do they need to resize it? And what's the process requirement? What are they actually trying to do? What's the purpose of the dosing requirement? What type of controls are required around it? You need to have a basic understanding of what they're looking for. Your customers should know this information. It's a bit of a disclaimer. Grundfos, as a company, make chemical dosing equipment. Grundfos are not chemical manufacturers, so we don't have a handle on what's behind what they're looking for. Grundfos do not offer consultant or analytical services. We're not out there pushing chemicals to make certain processes work. We're simply supplying the mechanical equipment to carry out the process. So Grundfos will not guarantee process performance. We can't say how much chlorine you need in a certain type of water to disinfect it, or how much pH you need to make a certain change. That is the work of a consultant or an agronomist or someone that's qualified to do that work. We're simply supplying the equipment to do the right job. However, with a few basic questions, we can make an educated guess at the right type of equipment to do the job. So certain questions the customer needs to have answers for are: what is the chemical and the concentration? What is the process pressure? What back pressure are we needing to do the dosing into? What power supply is available? No point offering a three-phase pump if only single phase is available. How do they want to control the pump? There are many different ways of starting, stopping, changing the output of the pump. We need to have a basic understanding of what they're looking for to be able to supply the right pump. What is the process water flow and dose rate required? How will the chemical be stored? And inevitably, where is the pump going to be located? All these are important questions that need to have answers to make sure we supply the right equipment to do the job. So what chemicals and concentration? Type of chemical and concentration determines things like pump head material compatibility, whether we're going to have degassing problems because the chemical is giving off lots of gas bubbles, fluid viscosity, whether we need to have special pump heads with spring-loaded valves or other means, requirements of slowing the stroking speed or something like that. Handling safety, whether the pump needs double diaphragm for extra protection in case the diaphragm should break. Site zone requirements, whether the chemical is flammable, whether we have EX rating requirements there. Another one is whether the pump head needs to be heated or the pipe's lagged because it will freeze when it gets cold. A lot of this information comes from the chemical label, particularly the chemical and concentration. And the customer has to have that information because he's the one who's got to go and buy it in the first place. So he needs to know what he's trying to dose and in what rate which is required. Process pressure, generally in bar. Plant process pressure determines if the pump selected will do the job. Dosing pumps only produce enough pressure to push the chemical into the process. It's a common myth we get that offer a customer a DDA 7.5-16, so it's maximum 7.5 litres an hour at 16 bar. And the customer comes back and says, yeah, my process is only 2 bar. If you offer me a 16 bar pump, it's going to blow up all my pipes. It doesn't work that way. A dosing pump will only produce enough pressure to push the chemical into the process. So the process is only 2 bar. It'll produce about 2.1 just to force that chemical into the process and do the job. It's only if you close off an isolation valve, deadhead the pump, that'll then produce 16 bar, and yes, then they might be in trouble. So plant process must not exceed the maximum pressure of the pump. No point offering a pump that'll only do 4 bar if the process, the water line that you're pushing the chemical into is going to go up to 8, 9, 10 bar. The pump will stall, it won't be able to do the job. Another important factor is the plant process must not be lower than 2 bar. When we're dosing into an open discharge line, there is no back pressure to force the gravity seeding valves in the pump to close. So it's important that there is some back pressure there for the pump to dose accurately to deliver the required amount of chemical. Another point on process pressure is depending on the volume per stroke of the actual dosing pump. A pulsation dampener may be required. If you're pumping a high volume per stroke into a high pressure, you're going to get a lot of shock loading from that reciprocal action of the diaphragm pump, and so a pulsation dampener may be required to soften that pulsing out. Available electricity. The plant power determines what type of pump you can offer. Digital pumps only come in single phase, so all the pumps with a LCD screen on them cannot be purchased in three-phase. Three-phase pumps, our DMX, DMH mechanical range, can be bought in three-phase in certain sizes where the motors are small, below 0.37 kilowatt. They can be purchased in single phase as well, so there are different types there. And what about solar or low voltage DC? For some of our small pumps, it's cheapest ways to simply buy a small inverter to change from DC power to 40 volt AC, and it'll run the pump quite happily. So there are often other options to look at there. Pump control. Type of pump control determines what type of pump you can offer. Most basic pumps simply have a manual stroke length adjustment only, what we call a set and forget pump, whereby you set it up initially, use the calibrated dial on the side of the pump to set an output, and every time you turn the pump on, the pump runs at that output. It's one that you don't need to change. You might want more than simply manual control, so you might need auto control, perhaps a paddle switch in the water flow that activates the dosing pump when there's water flow and stops the dosing pump when the flow stops. You may need to flow pace the pump. You may have a water line that the flow varies, increases and decreases, and so we need to vary the dose rate according to that water flow. So you may need a water meter with pulse control pump that will give you a meter, that will give you pulses per litre of the water passing through. Or an analog control signal, 0 or 4 to 20 milliamp flow pace control, maybe from a water meter or a chlorine analyzer or something like that. Batch dosing, perhaps you need to deliver an exact amount of chemical in a certain time period into a tank or something like that. So there are pumps that have batch control as a menu function, can be selected and operated. Or timer control, so you want to dose in that batch every 5 minutes, 1 hour, 10 hours, whatever you want to do. If you're getting really sophisticated, there are forms of bus communication, so Profibus, Modbus, different forms of communication that can be applied to certain dosing pumps. If we don't know what the customer is required, we can't provide the right dosing pump to do the job. Some other functions of dosing pumps that we need to look at may require additional accessories to the pump, like flow monitors, proof of delivery, pressure sensors, fault diagnosis and correction, and flow meter. All could be combined into certain types of our pumps. Might need an error alarm output signal from the dosing pump. The pump fails. It may need an analog output to show the actual value of the pump, its dose rate, as an output signal to a control system. Diaphragm leak detection. Should the diaphragm break, perhaps the customer would like to know whether that's occurred. Need to come and fix the pump. Chemical empty and level, chemical level empty and pre-empty switch, so that the pump can warn when the system is about to run out of chemical, or actually stop the pump before it runs out of chemical, so it doesn't drag air all the way through the system and takes a lot of work to reprime back up and to get it going again. Pump output run signal. Do we need proof that the pump is physically running? When we turn it on, how do we know? It might be kilometers away from where you are. If you need a pump that does everything, choose a digital pump. Digital pumps have most of these type of options included in there, or certainly the majority of them. DDA series, DDA dosing pumps certainly have flow monitors which provide proof of delivery, pressure sensor inbuilt, fault diagnosis and correction, and flow meter can be all incorporated into this series. DME, the larger dosing, doesn't have all of the above, but certainly has some of these outputs. It certainly gives your customer more information of what's going on in the dosing system. So the customer can't give you the size of the dosing pump it requires. There are formulas that you can use to size a dosing pump. The example I'm about to present is for disinfection. So if you use dosing chlorine or other disinfection chemicals into a water flow, we have some basic information. We can work out what the size of the pump required is to do the job. First piece of information we need to know is the process water flow. And this is generally talking in maximum water flow, cubic meters per hour or kiloliters per hour. Can do it in liters per second, but you've got to bring it back to a standard somewhere. And generally in dosing pumps, we talk about liters per hour output, which is why we talk cubic meters of water per hour as a standard figure to use. Second requirement is the dose requirement in parts per million or milligrams per litre. When we're talking chlorine, we use incredibly small amounts of chlorine to dose, to disinfect a water flow. So we're talking about parts per million of chemical requirement. The third one being chemical, technical ingredients. What's the actual chemical that we're dosing? And we often see chemicals labeled as all sorts of fancy names, but the actual technical ingredient inside is often the same. Things like sodium hypochlorite, hydrogen peroxide have a basic technical ingredient name. And from that, we also need to know the concentration. Most liquid chlorines come in the form of sodium hypochlorite, and it can be 10 or 12.5% solution. We need to know what that concentration is, because it's that 10 or 12% that's actually forming the parts per million of the dose requirement that we're talking about. So formula looks basically like this. The process water flow in cubic meters per hour multiplied by parts per million of the dose required divided by 1,000 gives us the answer of kilos per hour of chlorine, as if we're talking chlorine, so the actual base material we're doing. We then need to multiply that by the chemical percentage factor, which gives us the litres per hour of the chemical we're actually pulling out of that drum to do the job. Now, chemical percentage factor is quite simple to work out. It's 100 divided by the chemical solution. So if the chemical solution is 50% solution, 100 divided by 50 is 2. If it's a 25% solution, 100 divided by 25 is 4. Get down to 10% solution, it's the same. So 100 divided by 10, it's 10, etc. So it's quite easy to work out. So as a typical example, water flow, here we have 20 cubic meters per hour. We require a dosed volume of 5 parts per million of the chemical, and the chemical is sodium hypochlorite at 12.5% solution. So the equation is quite simple. It looks like this: 20 cubic meters per hour multiplied by 5 ppm divided by 1,000 means we need 0.1 kilograms of chlorine per hour, or 100 grams if you want to look at it that way. 12.5% is a percentage chemical percentage factor of 8, so 0.1 multiplied by 8 is 0.8 litres per hour, or 800 mils per hour of this 12.5% sodium hypochlorite solution. It's quite a simple equation. It gives you a guide to the type of dosing pump you're looking at. Other things we need to look at: chemical storage. Chemical storage determines type of suction we're looking for, suction lift or flooded suction. If with a suction lift, we'd need a foot valve because we need to draw out the top of the tank. Flooded suction is where the chemical is above ground, and so it's gravity feeding into the pump. Different types of chemical storage. They might be buying the chemical in 20-litre drums, 200-litre drums, or IBCs. Could determine if you're using a rigid suction lance, what length of suction lance you're doing. If you're using foot valves, it really doesn't matter. A flexible foot valve, you just cut the hose to the length you require, and away you go. The type of chemical storage certainly does determine which pump will do the job. People sort of think about pumps as being creating a vacuum to pull the chemical in. The reality is that diaphragm pumps are a pressure pump. They're forcing the chemical out. They're not designed to pull the chemical in. It's only the atmospheric pressure that's pushing the chemical through into the pump on suction stroke. So if we've got a suction lift of 3 or 4 meters, we might need to have a special pump that's going to give us that type of suction lift. It's all important for the information to size or determine the correct dosing pump. And finally, pump location. Pump location will determine whether the pump will last 25 years or 6 months. Don't put digital pumps out in the sun. Digital pumps have LCD screens. LCD screens go black when they get too hot. They can destroy the LCD screen. There's certainly a limit to the operating temperature of most pumps. But digital pumps, it's certainly below 40 degrees C. So if you're putting it out in direct sunlight, middle of summer, some sun temperature on a pump can get up around 65, 70 degrees C. The pump's really not going to last very long. Areas like northern Queensland where they get torrential rain, pump IP rating is only IP65. So in torrential rain conditions, certainly could be penetration of rain into the enclosure. And inside a digital pump, you have electronic circuits as well as the motor and everything else in there. You certainly want to keep it dry. Keeping away from high winds, which cause abrasion from dust and sand, things like that, certainly going to foul up the screen. You've got to be able to see what's going on that screen. So if you've got a lot of scratching on the screen, you won't be able to see how the pump is operating. So always advise customers to put the pump under cover, out of the way, even if it's on a pile of Besser bricks as this one is in a tiny tin shed. At least it's better than nothing, and certainly that pump has lasted 10 to 15 years. A few other things to consider are pump dosing accessories. If we're going to make a dosing system, pump by itself, we have to get the chemical from the drum to the pump, from the pump to the injection point. We certainly need to look at various accessories that might be required. So things like flow switch, perhaps to be able to turn the pump on or off, automate the process. Pressure gauge to be able to see what pressure the process is working. It's often a good guide to see if everything is working right. Pulsation dampeners, as we mentioned earlier, flow meters, calibration cylinders to be able to calibrate the pump to make sure the output is correct, degassing valves. There's a number of different accessories that could be required. Some of the basic ones, if you're drawing out of a tank, most definitely require a foot valve. We have foot valves that come as standard with no switch on there, so you drop them in. They're just a check valve and a strainer, or with pre-empty and empty switches, which can connect to the digital pumps and give a pre-empty warning and stop the pump when the chemical runs out. Pressure loading valve, there is no back pressure in the process. You might be dosing into a water pipe. It's simply open discharge into a tank. The dosing pump is not going to be very accurate if it doesn't have a significant amount of pressure to pump against. Pressure relief valve, if you're going into a line that could be closed off. Some chemicals like sodium hypochlorite give off gas bubbles, and that gas can simply generate more and more pressure even though the dosing pump is not operating. In a closed head line, it could build to a point where a line could blow off and spill chemical into the environment. The pressure relief valves should always be considered in all chemical dosing systems, because we are often handling very volatile and dangerous chemicals. There are such things as multifunction valves. A multifunction valve on top of the dosing system there, which will take the place of both pressure loading and pressure relief valves. They're only available to the small pumps, not available in larger ones. Another important accessory is the injection valve. The point where the chemical goes into the process water requires a quill to allow the chemical to be pushed into the process stream and not simply dribble down the edge of the pipe, where it might take considerable distance to mix through the water. It's one thing to put the right amount of chemical into the water, but if you don't mix it through, it's not going to do a very good job of the process that is required to do. And finally, discharge line. It's a delivery type. A, it has to handle the pressure of the process required. B, it has to be the correct size for the dosing pump. So it's important to have the right size there. Grundfos do offer complete dosing stations. DSA, it's a packaged dosing system with either 200 or 500 litre tanks with a certain size, digital pumps up to 60 litres per hour, all set up in a bund, so there's safety. So if there is a leak of chemical, it's all contained. The dosing station comes with pressure loading, pressure relief valves, 10 metres of injection tubing, injection valve, etc. It's a full package system. DSB, various sizes of DSB, up from 40 litre, 60 litre, 100 litre tanks, and even one that has the bund where you can, if you buy the chemical in 20 litre drums, you can simply pop the 20 litre drum in there. Comes with a foot valve, the pump, pressure loading relief or multifunction valve, and the injection valve and 6 metres of delivery tubing. So it's a full little package system there. I'm getting annoyed by somebody there. I assume you've seen that one. Sorry about that. And of course DSU, and all the dosing stations are in the dosing price list. So all available in the Grundfos dosing price list. Another factor to consider if we're offering a dosing system is measurement and control. Are we delivering the right amount of chemical? First one being dosing controllers. So Grundfos offer a range of dosing controllers. The new range that was launched last year is the DID analyzer and controller system. It can be used for measuring and controlling chlorine, chlorine dioxide, pH, electrical conductivity, etc. The DID-3 controls and measures up to 3 parameters at once, so we can be from the same water flow measuring and controlling chlorine, pH, and electrical conductivity, or free chlorine, total chlorine, and pH. This is quite versatile unit to do. If you're selecting control system, one of the things you must know is the chemical that you're actually trying to control, chlorine or pH, pH being acids or caustics, depending on which direction you're going, and the control range for the measuring range requirement, because the DIDs come in different sensors. As an example, for chlorine, a measuring range of 0 to 2 parts per million, or a measuring range of 0 to 20 parts per million is available. We must know which range you want to work in to offer the correct sensor for the job. You may want to control the dosing system off a water meter. Grundfos offer contact type water meters with pulse rates from 4 pulses per litre upwards, 1 pulse per litre, 1 pulse per 10 litres, 1 pulse per 100 litres. There are different ones available. What you need to know here, first of all, is the maximum water flow. So water flow in cubes per hour to be able to size the right size flow meter. The thing to check, particularly if you're using digital dosing pumps, is what the slowest dose rate is, minimum flow. The pulses get too far apart with the digital dosing pump, and the dosing pump doesn't run continuously. It will see a signal start to run, but because it doesn't know when the next pulse is coming in, it stops and pauses, and you get very intermittent dosing coming out. So it's important to know both your min and your max. When sizing, most important to know the max and to set up the right pulse rate. And also water meters with analog type. Grundfos can offer analog type, or ones with 4 to 20 milliamp output. These require a 11 to 30 volt DC power source, and this power source can come direct from the DID controller. There is terminals in there to link up the power source of the analog water meter to this one. Again, you need to know the pipe size and the maximum water flow in cubic meters per hour you're going to need to read to be able to size the right water meter for the job. So a few typical dosing system designs for you to consider. First one being a typical static dosing system, where we have a dosing pump sitting on a chemical tank, dosing into a process pipe through an injection valve, and simply dosing there, start and stop as required, a basic dosing system. We can then create systems that are flow pace controlled, so you don't need to be there. You might have an irrigator that's going to start up, and we simply have a paddle switch or a start signal from the irrigator control that starts the pump. But if we want to change the output according to the water flow, then we'll do it through flow pace control. We have a water meter with a signal going from the water meter straight back to the dosing pump that will then increase and decrease the output of the dosing pump according to the water flow going through. We can create compound loop control systems whereby we dose into a water flow. We then take a sample of that dosed water up through our DID controller, and we measure the amount of chlorine or pH, what pH is in that water. And if the water flow is varying, we also need a signal from the water meter so that we can vary the flow according to rapid changes in the process water flow. Finally, set point control. We're not using a water meter, we're simply dosing into the water flow. We're taking a sample out and we're measuring that chemical in that process water and determining by a preset dose rate, parts per million, in the DI controller, whether the dosing pump is delivering enough or not. Control will then increase or decrease the dose rate as required to meet that set point. So there are various ways of setting up these systems. As you see here, we have our flow direction where we are dosing before the sample point. So direction of arrow is dose first and sample afterwards. And this is where the majority of systems need to be set up. A few people will often set up so they're dosing, measuring the water, and there's no chlorine in the water, so they expect the controller to know how much to put in a one-pass system. If you can't see how much is in there, you have no idea whether you put the right amount in. So you always dose first and sample afterwards, except where we're doing a tank recirculation system, whereby we're going round and round. So now we can read what's coming back from the tank. We add more chlorine to that water. That water goes into the tank, and we measure on the recirculation whether we put the right amount in. So it's quite a few different system designs there to work on how to set them up. Some dosing applications, just to conclude this presentation. First one being disinfection, and disinfection being drinking water and many other things. But in many rural applications, it's for seedlings, nurseries and things like that, or for feedlots, chook sheds, as we said earlier, we're putting the right amount of chlorine or other disinfectant chemicals into the water flow to remove any pathogens, viruses, or any diseases that might be waterborne going into that process. Fertigation, obviously, is certainly a good method of applying fertilizer through the irrigation system. It means you can do little and often throughout the growing season of plants to make the crops yield well. pH correction. Many plants thrive better with different pH levels. It's often agronomists will require certain pH for the water going into the irrigation. So important to recognise that one. Soil surfactants, making sure the water penetrates into the soil. So soil surfactants can be put on through an irrigation system through dosing. Mineral supplements, used a lot in New Zealand in the dairy industry. Keep the cows fit and healthy, I guess, and things like that. And of course, a whole lot more. There's many different applications for dosing. Finally, if you are struggling for questions, we do have things like dosing selection forms. This form goes through the basic factors, and this is the one for disinfection. So it's looking at the key factors which must be filled in there. So dosing water flow, as in cubic meters per hour, dose rate, ppm, chemical technical ingredient, and the concentration. System head pressure is running and stopped. Important to know if there is any back pressure when it's stopped, and whether the chemicals can simply siphon through the system. A dosing pump does not have spring-loaded check valves to hold back the chemical in a flooded suction. So if your dosing point is lower than your chemical tank, the chemical can simply flow through that pump and it will overdose or continue to dose when the water flow is stopped. You need to know things like electrical power, control method, as we've talked about, chemical storage, you need a tank, or whether you're going to use the chemical drum that the chemical is supplied in. Installation point, whether it's we need to look at extra housing for it, protection, things like that. Run cycle, how often, how much it's going to work, of course the quantity of pumps, and many other requirements there, and they're all included in there. So that's the basics of dosing pump selection, dosing system selection, and I hope that gives you some ideas for what you're looking to provide the right equipment for the customer's needs. How did I do?
I think that's pretty good, Peter. Now, does anyone have any questions? Just type them below and I'll read them out. Here we go. We'll just give everyone a few minutes to type. In the meantime, Peter, if they wanted to get in contact with you about any of the things you've talked about today, are they okay to email you or phone you?
They most definitely can email me. If everybody phones, I've only got one set of ears to listen to it. But other than that, yes, you are more than welcome to phone me at any time, as a number of Thinkwater staff do on a very regular basis, which is quite pleasing. I have no problems with that either.
Okay, great. Do you want to just put
Unfortunately, there are times when I'm doing things like this where I don't answer the phone, so please bear with me. But if you leave a message, I will certainly come back to you as soon as I can.
That sounds great. Would you like to put your phone number and email in the chat box?
I can do that. If we go for the chat box and enter a message in there. go.
Excellent. Thanks, Peter. That was really good. I don't know if you wanted to make this presentation available to everyone. I can add it to our weekly newsletter if you think that would be worthwhile.
If people would like it, I can certainly get a copy to you.
Yep.
That shouldn't be a problem. We'll get Lawrence to bring it up or something, or I can email it to you. It's not that huge. Yeah, no problem.
Excellent, that'd be great. It doesn't look like we have any questions. There was a lot of technical stuff in there, so maybe people will probably read through the presentation, might get in contact like that.
Yep.
Yeah, but thanks again. I'll probably see you again soon.
Not a problem. All right. Thanks, everyone.
Thanks, everyone. See you next week.